Right. Let's press on with some other stuff. Now, last time we were talking about reading from files. We were talking about reading from files, and we know that Unix programs read from standard input and they write to standard output. But if they want to, inside the program you can actually open a file and read from that file as well. But that's kind of a separate issue, and we'll be looking at that a bit more in a minute. But a lot of Unix programs, the only input they do is from standard input, the only output they do is to write to standard output, and that's quite convenient because standard input is just a sequence of bytes, standard output is just a sequence of bytes. So in theory, the output of one program can go into as the input of another program. And Linux has, and Unix have a notation for that. It's this vertical bar or pipe. So you can run a command, pipe the output to another command, pipe the output to another command, and you can build up a big chain of filters which can do some quite useful things. So, I've already used pipes a couple of times. If I had a program that was producing lots of output, I'd run the output of that command through a pipe into the paging program called less, which allows me to view the output one page at a time. Similarly, I may have, when we were looking at the Fibonacci number, the recursive version, just to show you how many calls, I may have written the Fibonacci code, printed out each call to Fibonacci, that just produces this huge list of calls, or a huge amount of output. So to try and work out how many calls, we just take the output of the Fibonacci code and pipe it through a program that will count the number of lines. And then we know how many calls there were to the Fibonacci function. But multi-way pipes, I use them every day for doing stuff with student data. Alright, so let's have a look at probably the simplest filter, cat. Alright, so this is a version that assumes that we're not reading from standard input, we're actually reading from named files. But the real cat command actually allows you to not specify any files, and if you don't, then it reads from standard input. Still writes to standard output. So let's see what we can do to make this program behave more like the real cat. Alright, so what we want is if we've got an argument, we want to open the file with that name. Okay, argvi, we assume is the name of the file. We try to read it. If we can't read it, we give up. Actually, I'll deal with this stuff first of all. Alright, if we can open it, then we scan it and we print it to standard output. And then we close the stream. I talked about open and close before. Oh, that's not even complete. Oh, that's interesting. Really? What am I doing here? Oh, I'm in Vim. Wrong editor. I don't know why Andrew insists that we have to use gedit. Alright, close the stream. It's much better in Vim. No, so we're iterating over all of the command line arguments, each of which we assume is a file, and we open the file, we print its contents to the standard output, and then we close the file. And then we go to the next command line argument, open it as a file for reading, and scan through it, and if we manage to successfully open it. So kind of in the same way that scanf can fail, if you say scanf%d and you don't give a number, scanf fails. If you say fopen and you give a file name and you want to open it for reading, but the file doesn't exist, or you can't read it, then fopen is going to fail as well. When fopen fails, it returns a value of null, which is what we're checking here. Alright. Okay, so let's quickly have a look at how this works. I think I've got it compiled up already. And I had some small files, oh yes, that one. Right, so cat the small file, and if I really want to, I can cat it twice, which will read it twice and display it twice, so you can see the contents of the file appears twice. If I was to do /cat, it would simply stop. If I was to run the real cat command, it wouldn't stop. It would sit there and wait, and what it's doing, it's reading from standard input. So it's going to read each line that I type and then display that line. And you can keep doing that until you're extremely bored. And of course you terminate input by typing Control-D. So the real cat command understands if you don't give any command line arguments, you want to read from standard input. Our version of cat doesn't do that yet. The other thing I was going to do was to show you, if I use the real cat, and I say cat some file that doesn't exist, it tells me that it doesn't exist. If I try to read a file that I can't read, and I've especially made this file so that no one can read it, it'll say permission denied. Okay, so you get different errors depending on the different conditions. Now, our version of cat just does nothing. If it can't find the file, that's probably not great. You might want to have some information and readable. Also, just does nothing. Okay. So when you get an error, it's probably better if you produce some kind of error message than if you just do nothing. So let's try and fix cat so it can deal with standard input if you don't give any file names and it prints sensible error messages. Alright, the sensible error messages thing is pretty easy because there's a built-in function called print an error. And it's because Unix programmers are lazy, they don't write print error, they write error. And for that you can give a string, I think, and I'm pretty sure this thing will print an appropriate error message. Now there's stuff going on behind the scenes to make this actually work, but let's just test this out. So print an appropriate error message if the file can't be opened. Save. Okay. So if I do /cat, okay, same as before, it doesn't understand that I want to read from standard input. If I try to read a file that doesn't exist, now it tells me that. And if I try to read a file that's unreadable, it gives me a different error message. Okay, in fact, it uses the same kind of error messages that I'm getting from the real cat command. Okay, so this p error thing, how does it work out what the error is? Interesting question, because all we get back from fopen is that stream is equal to null. So in both cases, if the file's not readable or if the file doesn't exist, in both of those cases, stream is going to be equal to null. So there's got to be something else going on in the background. And in fact there is. all of these kind of, in fact, just about any function that deals with the system in C programs will set a flag if something goes wrong. And this flag sort of sits there in the background. It's a flag called ERNO, E-R-R-N-O, for error number. And p-error, the function p-error, can look at that value of ERNO and then print an appropriate message based on that. So p-error is using a little bit of information that's stored in the background when something like that fails. If fopen succeeds, you manage to open the file and read it, then error number will be 0, meaning everything is okay. Otherwise, it'll have a non-zero value, and this function called p-error is able to interrogate that value. But that's the only way we can distinguish those two different error conditions: non-existent file versus a file that exists but I can't read. From the programming side of things. All right. Next thing to worry about is how do we handle the case where there are no input files specified? Clearly we want to do something like this, but we want to do something like this with stdin. Now we could write all the code here. In fact, maybe we don't need to write all of this code, because this part of the code we don't need to do for standard input, because standard input is already open for us. So all we need is this piece of code here. Now, we could just repeat that piece of code, or we could take that piece of code and put it into a function. And if you want to treat this code here as being the actual guts of the cat command, then maybe you could put that in a function called cat. So let's do that. So this function doesn't have to return anything. What is its input going to be? Its input is going to be an open file stream. So the parameter type is a file star, and you can see that it's being used there. Alright, this chunk of code is actually part of the main program, so I better put it back there. Close off that, put that back. Alright. Don't need that. Alright, so we're going to iterate through the command line arguments. For each of those command line arguments, we're going to make sure that we can open the stream. If we can't, we're going to give up. But otherwise, what we're going to do, we're going to call the cat function on that stream that we just opened. Now, it would probably make more sense to actually do the fclose here, rather than inside the cat function, which is where I had it. And of course, all this stuff has to be shifted back. Blah, 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 blah. Always should try to make the program as neat. Like that. Alright, so this cat function takes in a stream and iterates through that stream, prints out each character in the stream, and that's it. So that's what we understand cat is supposed to do. One thing that I think I mentioned once before, and I hesitate to mention again, no C program would write this code like this with the two getC statements. What they would typically do is this. Exploiting the fact that C assignment statements actually return a value. And I mentioned this before. They return the value that's assigned to the variable. So what this while loop is doing here, it's got this first thing which is an assignment statement. So we're calling fgetC, we're assigning whatever the next character is to the variable C. That's the value of that expression that I've just highlighted, and then we're comparing that value with end of file. So that's a very common idiom in C. You know, I mentioned a couple of idioms last time, like I++ and the for loop. This is also pretty common. Now there's one little issue we have here. Where's C defined? Remember, functions run as their own little closed ecosystem unless I define C or pass C in to this function. I don't know what it is. So if I left it like that, I'm going to get a compiler error about C not being defined. So in fact, I can just grab this line from here and take it down here. So that doesn't change. C is being used to hold the current character in the file. Alright, so that's the entire cat function. Has the guts of what we want to do. We've given an open file open for reading, scan through a character by character for each character, print out the character. Alright, so that's nice if we're scanning through the command line arguments. Does anyone know how to push a whole block across in gedit? Let me just have a go. See if I can do that. No idea. Oh, well, it doesn't matter. In that case, I might end up with a really ugly looking program. Okay, so how do we handle the case where the user doesn't specify any files, no file names on the command line? What to do? Well, first thing, how do we detect that case? What did I say earlier? When you run a Linux program, argc always has a value at least 1, because argv will always contain the name of the command. So if argc is equal to 1, that basically means the command line only has the name of the command. So we haven't specified any file names. So in this case, what do we want to do? It's very simple. We just cat the standard input. So standard input is a file start, a stream that's always open when a program starts running, always available, and so I can, since it's a file start variable, I can just pass it as an argument to cat, where cat is a function that expects a file start. If I want to do that, I should try to just compile it up so it's wrong. And you can see, alright, let's comment that out as well. Alright, so let's try and compile this thing up. Oh, what's that? Control S, that's what I thought I did. Okay. Implicit declaration of function cat is invalid. That error comes because you've made use of a function and nowhere earlier in the program was that function mentioned. So you might say, what about printf and scanf? We don't mention them anywhere, but they get mentioned in standard io.h. Any functions that you have in your program, you either define them before main, or before main you put a signature which says what the type of the function is. So I need to put a signature for cat up the top of the file. So that'll do. It just says cat is a function that takes in a file pointer as input. Right. And all of these errors actually come about because of that error. Right, so I can compile again, still get an error, used an undeclared identifier, that's because I commented out the declaration of C. Line 41, so I'd go to the program, go to line 41, and I'd see here, oh, I've used a variable called C, I haven't defined it, so all I've got to do is define it, and that error will go away. And with any luck, there won't be any more errors. It's taking long enough. Good, okay. Alright, so let's see if other stuff still works. So catting that small file works. Catting it twice still works. Now the interesting one, if I type /cat, now instead of just doing nothing, it's waiting for me to type stuff, so it's going to behave appropriately there. And what else was there? Oh, just files that don't exist. Yeah, we already looked at that. Okay, no such file or directory, and the unreadable, unpermission denied. So we've got something that's plausibly like the Unix cat function now. Okay. So any questions on the structure of that program? Are you happy with this? Very common thing to do in C. Yeah?
Why do you use INC instead of char C?
Good question. Because that is not a char value. You can get away with it a lot of the time. But if you think about it, you're scanning through an input stream, you've got to be able to recognise when you reach the end of the stream, everything you see before that is a valid char value. EOF can't be a valid char value. Otherwise, how would you distinguish it from any of the other char values in the stream? So it's not a special char value. It's actually a value that has to be something different to a char. So normally when you're reading character by character from a file, you'd use int.c. In fact, a lot of the time you can get away with defining char C and it still works, luckily, because of the way EOF is defined. It just happens to be distinguishable from most of the other char values. But the safer. So defining this as a char will work on some machines, but not on others. Defining it as an int is guaranteed to work everywhere. Anything else on this program? Oh, I just realised something. So if argc is equal to 1, then I do cat, but I don't stop at that point. I keep going, and then I do this for loop. Now, that's fine, that's kind of harmless, because if argc is equal to 1, then this for loop is going to fail, or it's going to terminate without even executing the body of the loop once. So that's harmless. If I really wanted to, if I didn't want to bother even doing that that for loop, then at this point I could always do a return. So in this case it was harmless, but sometimes you maybe do not want to go on and continue executing anything else in the program after doing that. So let's just, of course, having made a change, we're going to go back and double check that things still work. Add X, Y, Z, yes. You probably want just /cat. Right, still works, still does the same thing. It wasn't wrong before, it was just attempting to execute a for loop, but because of the condition that we checked earlier, it was always going to not execute the body of that loop even once. Alright, so that's enough of cat. Well, let's see what else we have. Copy. Copy is a useful one. So far, all we've been doing is reading stuff. So this is intended to be an implementation of the CP command that Unix has, which you may have used at some point. So if I wanted to, I can say copy small to small 1, and that will make a copy of that file. And just to prove that it's a copy, I could always run the diff command. And small 1 have no differences, therefore the copy is just made a copy of the file. Alright, how can we implement that? So there are clearly two files. This is the source file, and this is, if you like, the destination file. So we're going to take the content of small and copy those contents into a file called small1. Now notice that small 1 didn't exist before I ran the copy command. Now it does if I did an ls. See, there we've got small and small 1. Alright, so first thing, we obviously need to have two command line arguments now. We need to have the input file and we need to have the output file. So there's going to be two stream variables involved in this command, and we're going to have a current character. Alright, so first thing, and here I haven't implemented it yet, I've just put in the comments that indicate my plan of attack, if you like. Alright, first thing to do, check that we got two file names. So how do we know that we got two file names? No idea. argc is a good starting point. argc is going to be 3 if we have two file names. I have the name of the command, the name of the source file, and the name of the target file. So if argc is less than 3, or you can even check if it's not equal to 3 if you really want to, then we want to print a usage message. Okay, so that will help the user do the right thing next time, and we're going to indicate that this command failed. Alright, so if we get to this point in the program, we know that we've got at least two command line arguments. Alright, so we said that the first command line argument, argv1, is the input file, so we need to open that for reading, and we've already seen how to do that. And now I'm going to cheat and do the same trick that I did, unless it turns out to be too long. Right, so we're running the fopen command, we're assigning the value to input stream, and then we want to check that it's equal to null. And if it is equal to null, oops, we have a problem. So I'm going to be lazy and use the error function to tell me what went wrong, and that is an exit failure. So that's an error condition. Attempt to open argv1 and open it for reading, and if it doesn't open for reading, if it does open for reading, then this will be assigned a valid file pointer value. If I can't open that file for reading, then input stream will be null, and that's what we're checking here. The value that was assigned to input stream shouldn't be null. Alright, this is going to be a little bit similar, so I may as well copy it. Attempt to open argv2 for writing. So we had another variable called output stream. Obviously it's argv2. And how do you open for writing? You specify a different mode. So there are three basic modes: R for read, W for write, and A for append. So W, create a new file whose name is argv2 is what that's going to do. It's possible that I can't write a file. Maybe I don't have write permission in the current directory, or maybe the file already exists and I don't have write permission on that file. So there are various reasons why that fopen for writing might fail. Alright, so, and whatever the reason, I'm going to get null back as the value for output stream. So that's handled that. Opening a file for write is an interesting or a slightly dangerous thing to do, because if the file exists, or if the file doesn't exist, it will make an empty file. If the file does exist already, it will make it empty. So whatever was in that file is gone. So you need to be a little bit careful about that. If you really wanted to, before you tried this open, you might want to check whether the file exists and then give them an error message saying you're about to overwrite an existing file. Do you really want to do that? Something like that. But in any case, this one's being dangerous and just opening it for writing, whether it exists or not. So if it doesn't exist, it will create the file. If it does exist, it will wipe out whatever was in it. Alright, and then copy input to output, that we know. That's so read the next character and check whether it was end of file. If it wasn't end of file, then we go into the body of the loop and we do whoopsie. So we write the character that we just read to output, and I think I defined C up above here. Current charge is already defined. Okay, so copying input to output is now very straightforward. And close the file, so it's always nice to close the files off at the end. And finish. Okay, so that's the whole program. Any questions on anything there? The output stream, we open the output stream for reading, so for writing, and we're writing into the file argv whose name is given by argv2, and then we simply read from the input stream right to the output stream. And hopefully that will give me a version of copy. No, it won't. What's wrong there? Comments. It's not a string literal. Alright, let's start here. So, what's the problem here? Ugly, damn ugly error message. Basically, it's telling me I've stuffed up something with my arguments to fprintf, and it's mentioning the fact that I've got a character argument where I should have a file start argument. Okay. Remember, the first argument to fprintf is a file stream. So I intended to write there fprintf to the standard error stream, blah blah blah, but I forgot to include standard error. So there's two ways I can fix that. One would be to not use fprintf, and I think I'll take that way out. So just use printf. And then I don't need to give a stream argument. Alright. Okay, so I've got this new command called copy. Let's try something initially. Let's copy A without saying where I'm going to copy it. Okay, so it complains argc was less than 3. Let's try to copy a non-existent file somewhere. A no such file or directory. Okay, that's cool. Well, let's try to copy small 1 to small 2. And right, it does something, don't know what it does. I can go into an ls, now I've got a file called small 2. If I wanted to check that it was probably the same file, I could do something like that, and I can see that all these 3 files are 39 characters. That doesn't prove they're the same. The only way that we could prove that is to either look at them or use diff. Okay, so diff tells me there's no difference. So that copy took from small 1 and produced small 2. Now, let's say that the contents of small 2 was extremely valuable, and if I do this, that's slightly unfortunate because it's going to take the contents of copy.c and overwrite what was currently in small 2, if I do the right thing. So now if I was to check small 2, I'd need to be comparing it, well, I can compare it to small 1, and I'm going to get a lot of differences. All right, I won't worry about the output format of the diff command, but if I was to compare the file copy.c to small 2, then I'd find they were the same. Okay, so what was in small 2 before is now gone. Right, so any questions on that? Otherwise we can go. I say, are there questions, or you can go? The choice is always going to be let's go. Alright, so let's go.